Alright, hello everyone and welcome back. So great work the last few days on 8.4, multiplying and dividing rational expressions. Today we're moving on 8.5, adding, subtracting. So you see I'm starting off example 1 here, adding a couple of fractions that have the same denominator. Of course that makes this much easier, just add the numerators together. 3 plus 1 is 4, denominator stays the same, the common denominator. So in number 2, I gave us an example with different denominators, still regular fraction stuff you've done before. Now, of course, you might easily approach this by counting by 8s, 8, 16, 24, and then counting by 12s, 12, 24. You'll find a common denominator of 24. But if we look ahead, that might not help us so much once we get to these rational expressions with variables and binomials. The idea of counting by, I'm not sure we're going to get those to match up with each other. So we're going to go back to number 2 and approach this old problem in a more detailed way. And that's taking the denominator of 8 and factoring it, like factor tree, like prime factorization. So I can see that that's 2 times 4. And then in fact that goes farther, like 2 times 2. And at the end I can see that 8 is the same thing as 2 to the third power. So then I do the same thing with 12, and I can factor that that is like 2 times 6, and then that can keep going and become 2 times 3. So then I can get the prime factorization here as 2 times 2, that's 2 to the second power, and after using those, then there's still this times by 3 that I have to take care of. So when I look at the prime factorization of 8 and the prime factorization of 12, now I look at each of their factors, and I pick the most amount of those factors that are visible. So here there's 2 to the third power, here there's 2 to the second. I pick the higher power of 2 to the third, and then I look at, like, there's nothing else here, but over here there's a factor of 3, and I'm going to take it because I always take whatever I have the most of. So while there's no 3's over here, I do have 1 3 over here. I'm going to take that because that's the most 3's that I have. And then if we multiply this out, 2 to the third is 8, and 8 times 3 is 24. Of course, that's the same common denominator you would have found the old way. But this is going to be much more helpful for us moving forward. So to quickly finish this one, now I want to make this become a 24. I can do times by 3. I want to make that become a 24. I can do a times by 2. And of course, you're going to get 3 over 24 plus 10 over 24 for a final answer of 13/24. So now let's move on to number 3 and kind of, the real main idea here today. So now, given denominators of 9x squared and 3x squared plus 3x, first thing I'm going to do is, once again, take those denominators, I'm going to section this off, bring them off to the side, and think about their factors. So the 9, for instance, is 3 to the second power. And the x squared, I'm just going to leave it as is, it's x squared. On the other hand, the other denominator, 3x squared plus 3x, I can factor a 3x out of there, and that's going to leave behind an x plus 1. You can check that 3x times x is 3x squared, and 3x times 1 is 3x. So now I look at these denominators, and I look for the factors they have, and always choosing the greatest number of them. So I look at, like, the 3's, and I choose 2 of them because that's the most amount of 3's that I have. I look at the x's, and I choose 2 of them because that's the greatest amount of x's that I have. And then that's all for this one, but over here there's a factor of x plus 1. And while there's no factors of x plus 1 over here, there is one over here. I choose this because it's the greatest amount that I have. So I take that x plus 1 along for the ride. So we've now found our common denominators, basically 9x squared times x plus 1. That's our common denominator. So now when I bring it back to the original problem, I look at the original denominator of 9x squared and I realize I'm missing an x plus 1. So I want to get that x plus 1 in over here. Now if I multiply by an x plus 1 in the bottom, that's going to make this denominator become my common denominator. I need to also multiply by x plus 1 in the top. And then I'm going to move over and set up my second fraction. So this time, while I had a denominator of, I'm going to put the factored form down here, that 3x times x plus 1. It's going to make it a lot easier to see what pieces we already have and what pieces we might be missing. So I'm going to take that 3x times x plus 1, and now look to see, I have a 3, but I want to have 2 of them. So I know I need another 3. I have an x, but I know I need 2 of them, so I know I need another x. I have an x plus 1, I already have an x plus 1, so that's all good. So I need another 3, I need another x. I need to multiply there by 3x, and then do the same thing in the top. So now you can see how that'll give you the 3 times 3 makes 9, the x times x makes x squared, and there's that x plus 1. So we're going to go ahead and actually multiply now. So 7 times x plus 1, that becomes 7x plus 7. And in the denominator, I get 9x squared times x plus 1. I'm just going to leave it like that for now. Over here, I get x times 3x. That's 3x squared. And in the denominator, well, I'm going to make it look like this one. So I'm going to multiply my 3x times 3x to make 9x squared. And then I'm going to leave my x plus 1 as a factor like that. And that shows me, of course, the denominators now match each other. So just like before, if the denominators match each other, I can add the numerators. So I look at 7x plus 7 plus 3x squared. None of those are alike. There's an x squared, a regular x, and then a constant. So I'm just going to basically rewrite this. I'm going to write it in descending order of degree. So I'm going to move that 3x squared up front, then the plus 7x, then the plus 7, and the denominator stays the same. So once you find a common denominator, now I keep it the same, and that's 9x squared times quantity x plus 1. That's it. You're welcome to stop right there. If you wanted to multiply this denominator out, you could, but otherwise this is a fine stopping point. So one last example for today, and it's another one, similar to what we just did, problem 4 here. A little more complicated by the looks of it. For starters, it's a subtraction problem. Keep in mind that means that eventually we're going to subtract all of this. And also I see these denominators, and they're certainly not like each other right now. In fact, there's a binomial and a trinomial. But I'm going to approach it the same as before, and that starts with taking the denominators off to the side and factoring them. So I write 2x minus 2, and I see there's a common factor of 2. I pull that out to 2 times x minus 1. I take the other denominator, x squared minus 4x plus 3, and I try to factor that. I'm setting it up like binomial times binomial, x times x. And then I'm looking for factors of positive 3. They must be the same as each other. That add up to negative 4. They must both be negative. So like minus 1 and minus 3. So now I'm looking at all these factors, and I'm always choosing the greatest number. So there's a 2 here. There might not be any over here, but I'm taking the most that I have, which is 2. There's one of them, so I take a 2. There's an x minus 1 over here. There's an x minus 1 over here. Now there's only one of them here. There's only one of them here. I take the greatest amount possible. It's just one of them. It's the most possible from this or the most possible from this. So when there's one here and one here, the most I can take is just 1. And then that's everything here. So over here, there's just an x minus 3. And I do need that. So then I take the x minus 3. So now I look at, back to the original problem. Again, it really helps to now write these denominators in their factored form. And that makes it a lot easier to see. I already have a 2. I already have an x minus 1. What I really need down there is an x minus 3. But I have to do the same thing up top. Then there's my big minus sign in the middle. And now my other fraction, negative 2x minus 1 over. Again, it helps to write that in factored form. So x minus 1 times x minus 3. And then when I check the denominator, I see that I already have the x minus 1, I already have the x minus 3. All I'm missing is the 2. So all I need down there is a 2. But then I do the same thing up top. So over here, I'm going to multiply these together. That's x plus 2 times x minus 3. That's x squared. And then I get minus 3x plus 2x. That becomes minus 1x. And then 2 times negative 3 for negative 6. And all over, I'm going to leave that denominator all factored as 2 times x minus 1 times by x minus 3. There's my big minus sign in the middle. I'm going to distribute that 2 so it becomes like negative 4x minus 2. And again, I'm going to leave this in factored form. I'm going to move the 2 up front just so it matches my other denominator. And now that the denominators match, I'm ready to go ahead and put it all together. The denominator stays the same. I'll go ahead and get that out of the way since it's easy. And up top, I need to do all of this minus all of that. So you can write this a few different ways. We've seen this earlier this year. I'm going to go vertical for this one, line up my like terms. And it's x squared minus nothing. The x squared stays the same. Then it's negative 1x minus negative 4. That's negative 1. It becomes plus 4. So I get a plus 3x right there. And then that's negative 6 minus negative 2. That's negative 6. This becomes a plus 2. So that finishes as a minus 4 or negative 4. So when I do all of this minus all of that, here's what I get. X squared plus 3x minus 4. Now, this might look like, you're basically done, but anytime you get a new numerator like this, we can consider whether it can be factored, whether something might cancel. I didn't mention that back in number 3, but this one can't be factored. So that's how I knew I came to a good stopping point right there. This one, however, if I factor the top as a product of binomials, and I look for factors of negative 4, one positive, one negative, that add up to positive 3. I can use a plus 4 and a minus 1. That multiplies to negative 4, adds up to positive 3. And what you might notice at that point is that there's a factor of x minus 1 in the top and a factor of x minus 1 in the denominator. So that x minus 1 up there, that x minus 1 down there, they can cancel. And then I finish with just x plus 4 over 2 times x minus 3. So then that's it for today. That's adding, subtracting rational expressions. If you could work on the few practice problems for today, I'd really appreciate it. Thank you very much.